So let's revise the what we have discussed earlier about the Murray machine. So the finite automata with output. So there are two types: Murray machine and Mealy machine. So Murray machine, uh, in case of Murray machine, every state there will be one output. Some output is associated with every state, um, and the output which is associated with the state, it is not dependent on the input which that state will receive. So if you are on that particular state, it means that output will be generated irrespective of the input that state will receive. So whereas in case of Mealy machine, the output generated by the state, it depends upon the input which that state will receive. So this is the difference between the Murray and Mealy machine. And depending on that, here this is what is the definition of formal definition of Murray machine. So you can see here there are six tuples, and meaning of almost all tuples is same as what you know, or it is same as the finite state machine which we learned earlier. So here capital Q, it is nothing but a set of states that you all know. Then sigma, it is a finite set of input symbols. Then, as I told, that each state will generate the output. So, depending upon what symbols those states will generate, depending upon that, there will be a O. So, this O will have the all symbols uh, which each state will generate as the output. Then delta, small delta, it is nothing but the transition function of the Murray machine, and capital delta, it is a MF of the Murray machine, and Q0, it is nothing but the initial state from where your processing will start. Now this is the problem: residue modulo 3 for binary number. So it means you have to divide a number by 3. Earlier such type of problem we have done, but that time the number to which we were dividing, that number was a decimal number. Here the difference is, now we are dividing a binary number, and we have to design a Murray machine that will tell that after division of a binary number by 3, what is the remainder, right? So here, um, these are few observations which you should note, that if we have a binary number I, then if after this binary number, any binary number, now this I, as I said, it is a binary number, it means this I can be either 0 or it can be 1, right? So after this I, either there will be a 0 or there will be 1. These two possibilities are only there because in binary number we have only two digits. So when you will add 0 to the binary number, now if I'll say I is a single digit, then it can be a 0 or 1, or it can be multi-digit number also. But if you will add 0 after that number, then the value will be double, right? And for example, here, if your I is equal to 1, binary 1, and if you add 0, you will get 1 0. So this is binary 1 0. So its decimal equivalent is 2. So when it is binary 1, so decimal equivalent of this 1 is also 1. But when you will add 0 to it, it becomes 2. That is 1 0. Similarly, if we have a binary number 1 0, so this is 2. Decimal equivalent of 1 0 is 2. When you will add 0 to it, you will get 1 0 0, and that is equal to 4, decimal equivalent. So you could see that if you'll add 0 to the binary number, its value becomes double. And if you add 1 after the binary number, then it is observed that the value which you will get, it is nothing but 2i plus 1. So for example, if it is 1, if you will add 1 to it, you will get 1 1, which is 3 decimal equivalent. So it is 2i plus 1. So you could say 2 into I plus 1. If it is 11, so 11, you know, again it is 3. If you will add 1 to it, so what we will get? 111, which is nothing but 2i plus 1. So it is 7. So this is how these are the observation. I want you all to take a note of it. You write it down because this is going to help a lot when we will solve the problem. So I want you all to note it down. Okay, now you all know that when you will divide a number by 3, the possible reminders which you will get are nothing but 0, 1 and 2, right? So if we'll consider it, wait a minute. So the possible remainder, as you know, it is 0, 1 and 2. Now, let us consider a case in which reminder from the previous result is, let's say, 2, right? The remainder from the previous result is, let's say, 2. So what it will be? It will be binary 1 0. If I said you are dividing, you have to divide a binary number by 3, and if you are assuming the remainder is 2, that is 1 0 in binary form. Now if we write 0 after it, so you know that it becomes 4, that is 1 0 0 in binary form. When you will divide this 1 0 0, that is 4 decimal equivalent by 3, the remainder will be 1. So in this particular division process, we know that we will read the input from left to right, one digit at a time. Now the digit we read, you know, it will be divided by the divisor 3, and and you will get some reminder, and the next digit will be concatenated to the remainder, right? You all know this process, that we do the division, we got some remainder, and to that remainder the next digit will get concatenated, and then combine what number you will get, that you will divide by your divisor. Again you will get some remainder, and to that you will add the another digit. This way you will continue till you do this for all the digits in the input string. So considering the same thing, now let's say you have 3 states, one state for one particular remainder. So when I'm explaining, I want you all to draw this. So as I said, we have 3 remainders, 0, 1 and 2, and there will be a one state for each of these remainders. So you will be having Q0 as one state, that will produce output 0, that is remainder 0. There will be another state Q1, and you will make its output as 1. It means the Q1 will generate remainder 1, and there will be a Q2. It means this Q2 will generate remainder 3, or a output 3. Sorry, output 2. So Q2 will generate remainder 2. So I want you all to draw these 3 states on your copy, and our initial state from where we'll start our execution is Q0, right? Once you draw the states, and below the states outside the circle, you write there remainders, that is the output which is associated with it, 0, 1 and 2. Yes, done.
Hello,
Hello. Yes.
ma'am.
Huh.
The screen is stuck actually, showing the previous slide.
Your voice is not clear.
I think it's showing the previous slide.
Hmm.
And
I'm on the previous slide.
the ma'am, actually the presentation you are sharing is showing the previous slide. It's
Okay.
stuck, I think.
Now, what is there on your screen?
Ma'am, it's residue model 3 for
Uh-huh.
binary number.
Yes. So it is the only screen which I want to show, right? And what
Okay,
I am
okay, ma'am.
expecting is you should make three states: Q0, Q1, Q2.
Okay,
If
ma'am.
you know
Okay,
what
fine.
it is, you just make a circle. Inside circle, you write Q0, you make another circle. There you inside that you write Q1, you make another circle. Inside that you write Q2. And below each circle, you just write 0 for Q0, then 1 for Q1 and 2 for Q2. Clear? Till this it is okay?
Yes, ma'am. Done.
Yeah, done. Okay. Now you know why this 0, 1 and 2, why you have written 0, 1 and 2 there.
Yes, ma'am.
This is the output of the
Within
state, right? It means Q0 will generate output 0, यानी उसका remainder will be 0. Q1 will generate 1, means the remainder will be 1. Q2 will generate 2, means the remainder will be 2. Okay. Now your initial state is Q0. So make an arrow there to indicate that your Q0 is the initial state. Done?
yes, ma'am.
Okay. Now assume that initially, as I said, you will be processing input from left to right, one digit at a time. So assume that your first digit is 0, binary 0, right? So to binary 0, the next number which can get concatenated will be 0 or 1. Agree?
Yes, ma'am.
Right. So if you are on Q0 and uh, the output or a result of, assume that the result of previous division is 0, and that is the reason you are on state Q0. So it means to that remainder 0, you will be adding 0. So what you will get? You will get two zeros. When you will try to divide this two zeros by 3, so what will be the remainder? 0 only.
Yes, ma'am.
Yes. So it means on, so when Q0 will receive input 0, it will remain on the state Q0 only. Clear?
Yes, ma'am.
Right. Now, after either, as I said, you can there you can concatenate either 0 or 1. So when you have concatenated 0, you know what has happened. Now when you will concatenate 1, what will be the binary equivalent of decimal equivalent of 0, 1?
2,
0, 1. 1 0 nahi, 0 1.
1.
It is 1.
1.
So it means what? When you will try to divide this 1 decimal 1 by 3, what will be the remainder?
1.
1, right? So it means you should reach to that state which will generate remainder 1 from Q0. So which is that state?
Q1.
Q1. So from Q0, now you will move to Q1 on input 1. Clear?
Yes, ma'am.
Yes. Now currently you are on Q1 state with remainder as a 1. So now if you have a remainder 1, then the next digit, if the result of previous division is 1, that is remainder जो पहले का डिवीजन किया है उसका रिमाइंडर आपका 1 आया है, and that is the reason you are on state Q1. So to that remainder, the next digit which you can add, जो concatenate होने की possibility है वो, that is what? That is 0 or 1. So assume that to that remainder 1, I have, there is a next digit is 0, right? So what is the binary decimal equivalent of 1, 0?
2.
2. So 2 by 3, if you'll do, what will be the remainder?
2.
2. It means after, when you will have when you will concatenate 0, you are getting remainder 2. So you need to move to that state which will generate remainder 2. So what you will do? From Q1, you will navigate to Q2 on input 0, right?
Yes, ma'am.
Right.
Yes.
Yes. Now you are on Q1 again. So you have checked the possibility with 0. Now after 1, with that 1 as a remainder, the next digit which you can concatenate is 1. The another possibility also we have to consider. So you will get 1, 1. So what is the decimal equivalent of 1, 1?
7.
3.
1, 1. On 3. It is 3,
3.
right? So when you will divide 3 by 3, what will be the output? Remainder?
0.
0.
0. It means what? From Q1, you will have to navigate to that state which will generate remainder 0. Yes?
Yes, ma'am.
So from Q1, you will navigate to where?
Q0.
Q0 on input
Okay.
1. Clear?
Yes, ma'am.
Yes. Now we will move to Q2 state. So Q2, it generates, it means you are on Q2 state, it means you got remainder as 2. So after 2, you can, there can, the next digit which can get concatenated will be 0 or 1. So when you will concatenate 0, so what binary number you will get?
4.
1.
1, 0, 0. That is
2.
4, right? You are on state 2. That means remainder is 2. Binary equivalent of 2 is 1, 0. Fine. So to this
Yes,
1,
ma'am.
0, if you will add concatenate 0, which binary number you will get?
1, 0, 0.
1, 0, 0. So uska decimal equivalent is what?
4.
4. So 4 by 3, what you will get?
1.
1. It means when you will add concatenate 0 to 2, the remainder will be 1. So you will need to navigate to that state which generates remainder as 1. So where you will go?
Q1.
Q1. So Q2 on input 0, you will navigate to Q1, right?
Yes, ma'am.
Yes. Now another possibility we need to check. So now if you have 1, 0, that is 2, binary equivalent of 2 is 1, 0. Now to that, if you will add concatenate 1, what you will get? Which binary number you will get?
1, 0.
1, 0, 1. Uska decimal equivalent?
5.
5. So 5 by 3. Remainder क्या होगा?
2.
2. So it means when you will concatenate 1, you need to be on the state which will generate 2 as a remainder. So there will be a self loop, right, on Q2 for 1 as a input. Right?
Yes, ma'am.
Done?
Yes, ma'am.
Now cross check your state transition diagram. Is it correct?
Yes, ma'am.
Yes. And now you can test for this input string 1001. 1001, what is the decimal equivalent of this?
9.
9 hai, okay. So when you will divide this 1001 by 3, that is 9 by 3, what is the expected remainder?
0.
0. So now you can test your graph and check whether you are getting output as 0 or not. Similarly for 111 and 101.